Aloha, artificial intelligence has been growing at the pop culture speed. The question is, will the development of artificial intelligence hit a plateau? Let's explore this fascinating journey. In 1968, American artist Andy Warhol predicted that, in the future, everyone will be world famous for 15 minutes. This quote expresses the concept of fleeting celebrity and media attention. In the age of generative AI, Andy Warhol's prophecy echoes louder than ever. Every model is famous for 15 minutes. Artificial intelligence has been growing at the pop culture speed. Large language models are similar to celebrities. They rise fast, trend for a moment, then get dethroned. Look at what has been happening in early 2025. In January, DeepSeek R1 stunned everyone with insane capabilities in reasoning and math. In early February, ChatGPT fired back with version 03, nudging the bar higher. In late February and early March, Qwen 2.5 enters the market and crushes other AI models, especially in multilingual and code-heavy tasks. In March 2025, Google Gemini 2.5 Pro suddenly becomes the new benchmark king in reasoning, long context, and multimodal tasks. This is not just fast-paced, this is accelerating. Each champion barely holds the crown before someone new comes knocking. Just like any other tech curve, such as Moore's law for microprocessors, AI can't grow infinitely in capability, speed, or intelligence without hitting some hard ceilings. The key question is not if, but when this plateau might arrive, and what form it will take. Right now, we're still climbing steeply, but the signs of future limits are already coming into view. One of the most immediate constraints is raw computational power. Training today's cutting-edge models, like GPT-4 or Gemini 2.5, demands enormous hardware clusters, vast energy consumption, and staggering financial investment. As we push further, the cost per improvement keeps rising, and soon, we may reach a point where scaling is no longer economically viable. Alongside that, there's a growing concern about data saturation. Much of the internet's high-quality, human-generated content has already been consumed in model training. To rectify the situation, synthetic data, artificially generated information, have been utilized. These data are produced by algorithms rather than collected from real-world events, that mimics the structure and patterns of real data. Major tech companies like OpenAI, Anthropic, NVIDIA, and Meta are already incorporating synthetic data into their workflows, using it to simulate rare events, generate aligned responses, or augment datasets for domains like healthcare, finance, and autonomous driving. It allows precise control over data characteristics, enabling targeted learning and model robustness in edge cases. However, synthetic data comes with notable limitations. If generated from biased models, it can perpetuate or amplify existing biases. There's also the risk of model collapse, where models trained too heavily on synthetic inputs, especially their own past outputs, lose creativity, diversity, or factual grounding. Despite these concerns, synthetic data is rapidly becoming a foundational component of modern AI development, balancing innovation with efficiency in an increasingly data-constrained landscape. Another sign of a coming plateau is the diminishing return on model upgrades. Early jumps from GPT-2 to GPT-3 or from GPT-3.5 to GPT-4 delivered massive capability gains. Today, however, improvements are becoming more incremental, impressive, but less groundbreaking. The race has shifted from dramatic leaps to marginal optimizations, often visible only through benchmark scores or specialized tasks. Add to that the rising complexity of aligning more powerful models with human goals and safety standards, and you start to see how technical progress may begin to slow, not for lack of ambition, but because the challenges are becoming exponentially harder. Nevertheless, we're far from done. There are still massive innovations in the pipeline that go beyond simply scaling model size. The next wave of AI is about making systems more useful, more adaptive, and more deeply embedded into how we work and interact. One key frontier is the rise of agentic AI, models that don't just respond to prompts, but can autonomously plan, make decisions, and carry out multi-step tasks. AI agents like AutoGPT or Devon can break down a complex goal, such as building a website or debugging a codebase, execute individual steps, and even use external tools or APIs without constant human input. But if you're thinking of letting your agent AI handle emails from your boss or your girlfriend, just make sure it actually speaks your mind. Otherwise, you might find yourself accidentally committing to a weekend project, or a weekend getaway. Another leap is multimodal reasoning, which allows AI to process and synthesize information across different data types like text, images, code, and audio. A multimodal AI could, for instance, look at a photo of a broken machine, read a maintenance manual, and explain how to fix it, combining vision, language, and technical knowledge in one flow. Models like Gemini and GPT are already showing early promise here. We're also moving toward personalized AI models that adapt to individual users' preferences, work styles, or domains. Instead of one-size-fits-all responses, these systems learn your vocabulary, goals, and even your tone over time. Imagine a writing assistant that mimics your voice or a coding AI that learns your project structure and style. Finally, breakthroughs in long context memory and tool use are pushing models closer to real comprehension and utility. Long context memory allows an AI to retain relevant details across thousands, even millions, of words, enabling it to hold rich conversations, recall earlier parts of a document, or track ongoing projects without losing context. Tool use means models can augment their thinking with external capabilities, like searching the web, generating charts, or executing code, making them far more powerful and accurate in dynamic tasks. So, will artificial intelligence hit a plateau? Almost certainly, but not yet. What we're more likely to see is an S-shaped curve, rapid exponential rise, followed by a tapering into maturity. In that phase, artificial intelligence will become less flashy and disruptive, and more stable, specialized, and indispensable. The fame of each new model may just come and go, echoing Andy Warhol's prediction, but the enduring impact of AI will only deepen as it moves from novelty to infrastructure. If artificial intelligence companies simply continue along the current trajectory, scaling compute, feeding in more data, and refining algorithmic efficiency, the future may feel relatively predictable. Every few months, a new model from OpenAI, Google, Anthropic, DeepSeek, or others will dethrone the last champion, pushing performance up by another percentage point or benchmark score. But history teaches us that technological advancement is not just cumulative, it's disruptive. As Thomas Kuhn argued in The Structure of Scientific Revolutions, real progress often comes not from refining the old paradigm, but from a paradigm shift that redefines what's even possible. That next shift might be quantum computing. If researchers succeed in realizing stable, scalable quantum systems, the computational ceiling artificial intelligence faces today could vanish overnight. In that world, artificial intelligence might not just surpass today's limits. It could leap into entirely new territories of intelligence, abstraction, and creativity that classical machines could never reach. While a plateau may be coming, it's just as possible that a whole new dimension of AI capability is waiting to be unlocked. So, what's your take on all this? Do you think artificial intelligence development is heading toward a plateau? And if so, will we linger there for a while? Or is something bigger on the horizon? Is quantum computing just around the corner, waiting to redefine the game entirely? And beyond quantum computing, what other transformative technologies could spark the next revolution in artificial intelligence? I'd love to hear your thoughts. Drop them in the comments below. And if you found this video helpful, don't forget to like, share, and subscribe. Thanks for watching, and stay curious. Mahalo.